Okay, we got another absolute value inequality. We got to make sure that we take the absolute value and get it by itself. So we are subtracting 6 from both sides. So we get a 3 times the absolute value of m divided by 5 is greater than negative 3. And you can divide both sides by a 3. And then you're going to get the absolute value of m divided by 5 is greater than a negative 1. Sorry. There we go. So here's the deal, guys. When you get the absolute value is greater than a negative number, as long as it's strictly greater than the negative number, doesn't it make sense that no matter what we plug in for m, no matter what we get inside here, the absolute value is greater than a negative 1? That statement is true, and it's going to be true for all real numbers. So you can actually highlight the entire number line. Okay, and you can write it as, oops, I thought I was back in the pen. You can write it as the set of all reals. Okay, and just a little note aside, I'll put it in purple. Okay. If you'd gotten the absolute value of m plus 5 was less than a negative 1, or even, when you'd done this, you'd gotten greater than or equal to, then you got some issues. But because it was strictly greater than over there, you're all numbers, you're all real. But over here, if you get something that says the absolute value of anything is less than a negative number, that is no solution. That's a contradiction. You are not going to get the absolute value of anything being less than a negative number. It's kind of like when you were doing equations, right? You got to watch out for those negatives.